We are now going to get into our actual trig functions. The last couple sections we were really just hitting a few geometry pieces and a couple things that will be helpful for us moving forward. So today we are going to first come up with the definition for all of the trig functions. And these are the only trig functions, and we will use them for the rest of the semester. So first, I have a question. You don't necessarily have to write this slide down. This is just something for us to talk about. So if I have an angle in standard position, what's standard position?
Starts on the x-axis.
The vertex is at the origin. It starts on the positive x-axis. Okay, I didn't say what quadrant it was in. It could be in any of them, so let's just pretend it was here. So this is my angle. A lot of times angles have a Greek letter for their name. Theta is this one. It's just a Greek letter. It just means a variable. Okay, it's just the name of this angle. And point P has coordinates x, y on the terminal side of angle theta. So the terminal side is the ending side. And somewhere on that I have a point for a pair x, y. If I want to know how far is it from here to here, could we come up with an expression to find that? There's really two different options. We could do the distance formula. Remember we did talk about that last semester in college algebra. Or we could do, like, think of it as a right triangle and do Pythagorean theorem. Okay, both ways will work. If you think Pythagorean theorem, that might be a little bit easier. If I just think of this as a triangle, from here to here would have to be x. How far is it from here to here? Y. I'm going to call this side r for a moment. Okay, so if I ask you to find r, x squared plus y squared equals r squared. How do you get r then? Square root. Normally if you add a square root, I've always told you you have to do plus and minus, but can a distance be negative? No. So r is the square root of x squared plus y squared. All right. So if you wanted to write something down, this would be the piece. In the next slide, when I use the definitions, they're going to have r in there, and so I want you to know where r came from. It's the square root of x squared plus y squared, or think of it as a triangle. It's that hypotenuse there. All right. So now, this is what's really important. So if x, y is any point other than the origin on the terminal side of an angle in standard position. Okay, it's up to you if you want to write this little blurb or not. You don't have to. It's going to be kind of the assumption for everything moving forward. These functions are the 6 trig functions, and they are the only 6 trig functions, so the only ones we will ever have. This, it's not sin, it stands for sine. So this is called sine of theta. And the definition of sine is y divided by r. So all of these are found just by dividing two things. The COS, that's called cosine of theta. And the definition of cosine is x divided by r. Tan, this is called tangent of theta, is y divided by x. All right. These other three are reciprocals. CSC is called cosecant, and it is just the reciprocal of sine. So it is r divided by y. SEC, this is called secant. And that is r divided by x. And the final one is cotangent. It's a reciprocal tangent, so it is x divided by y. So these are like definitions, okay? This is just, when you see sine, this is what it means, y divided by r. We are going to look at a lot of problems involving this. We won't even finish this section today, so we'll practice it today, Monday, ongoing, it's not going away. So we will get a lot of practice with this. The sooner you learn the 6 ratios, the better off you're going to be. Really, sine, cosine, tangent, those are your main ones. The other 3 are just reciprocal. So you just kind of have to remember which ones go with which. So we'll talk about a lot of different tricks to help remember that as we go. One trick that we can use is SOHCAHTOA. Have you guys ever heard that phrase? Okay. So it only really applies in a triangle. And not all of our scenarios will have a triangle, but it's a good tool for remembering. So I want to show you that trick. So SOHCAHTOA is for in a triangle. Okay. The trig functions, they have to have a right triangle, so we'll always have a right angle in here. And if you're doing a trig function, you always have to have an angle that you're looking from. So let's say this is my angle theta. That's my viewpoint from there. What's the side across from the right angle called? This side across from our angle we refer to as the opposite side. And the side touching the angle, that's not the hypotenuse, is the adjacent side. So if we think about that, we can say sine SO is opposite over hypotenuse, SOH. So in a right triangle, to find sine, you do the opposite side divided by the hypotenuse. CA is for cosine. It's the adjacent side over the hypotenuse. CAH. TOA, tangent, is the opposite divided by the adjacent, TOA. And this isn't like contradicting the X, Y, and R definition that I gave you, because if we think about this, if this were at the origin, this side would be X, the amount you go up is Y, and we call this R. So sine, opposite over hypotenuse, is Y over R, which we wrote down previously. Cosine, adjacent over hypotenuse, is X over R. Tangent, opposite over adjacent, is Y over X. So it's just another tool for remembering. I think triangles are probably a little bit easier. SOHCAHTOA kind of sticks in your brain a little bit better. But there are scenarios where we have an angle where we can't draw a triangle. And we'll talk about some of those probably Monday. So we need the X, Y, and R in that scenario. All right. Any questions so far? We have our definitions written down. Let's try to actually use them and see what I'm asking you to do. Now, if you're writing down this example, you really don't have to write everything. So we have an angle that goes through the point 12, 5. And I want to find all 6 trig functions. So you could just, if you're writing down in your notes, I would just say an angle passes through 12, 5. So I need all 6 trig functions. When we think about these definitions, we have x, y's, and r's. Do I know what x is? Yeah, that's 12. Do I know what y is? 5. Okay, to get r, we wrote down a formula at the beginning, but if you forgot about it, you could even think about a picture. Okay, my x is 12, my y is 5. How do you find that missing side? You can work out the Pythagorean theorem every time, or you can remember r is the square root of x squared plus y squared. Okay, I don't care which way you go. In my experience, some people, one less thing to remember if they actually just see the triangle and do Pythagorean theorem every time, which is totally fine. R is always positive because it's a distance, so if you do the square root of 169, we get 13. So the very first thing you have to do, if I give you a point, you have to find R. Now we just have the 6 ratios. You do have to have the theta symbol, the angle. It seems kind of silly now, I know you just want to make things shorter, but it's kind of like having a square root symbol with nothing underneath, if I just write sine. I have to know what am I taking the sine of, so we need that angle. So sine of theta, if you want, you can draw this triangle and think SOHCAHTOA. Sine is opposite over hypotenuse. I could think sine is y over r. Both ways, I get 5 over 13. You do need to put this in lowest terms. If it reduces, do that, but keep it as a fraction. Because if I know sine, I can get its reciprocal. The reciprocal sign is cosecant. And you just flip it, r over y, so 13 over 5. So we want our answers as fractions in lowest terms. Cosine. What's the definition of cosine?
X over R.
Mm-hmm. If you prefer to think about your triangles, SOHCAHTOA, adjacent over hypotenuse, either way we get 12 over 13. Reciprocal of cosine is secant. So all you have to do is flip it, so 13 over 12. Okay, I'm writing the definition as I go. I don't care if you do that. If you just say cosine of theta equals 12 over 13, that's fine. Last ones, we have tangent of theta. The definition of tangent is y divided by x, or the opposite side divided by the adjacent side. So that gives us 5 over 12. Cotangent, x over y, so 12 over 5. It's a lot of writing, but not necessarily a lot of calculating. It's just writing a ratio here. Do you guys think you could try one? So we have an angle passes through 8, negative 6. Give me all the ratios. Our first point is 8, negative 6. So what is my x? 8. My y? If you want to find r, you can use the formula. We said r is the square root of x squared plus y squared. If you don't remember that, draw a picture. 8, -6 would be over 8 and down 6. Okay, so this would be like my triangle here. So it's just Pythagorean theorem. So 64 plus 36 is 100. And the square root of 100 is 10. So R is 10. So either way, use the formula or draw yourself a picture, one or the other, to get your value. So then if I ask for sine, so I might remember sine as y over r. If you prefer a triangle, think sine is opposite over hypotenuse, so -6 over 10. I did tell you I want that in lowest terms though, so how can you reduce that? So then cosecant is CSC, that's the reciprocal of sine. So what's my cosecant? So you can just take that final answer and do the reciprocal. Cosine, the definition of cosine, x over r. Or if you think about your triangle, adjacent over hypotenuse. So that's 8 over 10, which is 4/5. Reciprocal of cosine is secant, so that would be 5/4. Tangent of theta, tangent is y over x, or opposite over adjacent. So -6 over 8, or -3/4, so that means cotangent of theta is -4/3. How are we doing on that? Let's do one more. One final one, we'll stop for today. Oh, shoot. Actually, maybe I want to stop here. Okay, I'm going to stop here, I think. I'm going to do the other kind on Monday. But I'm stopping early so that you're practicing in class and asking me questions when you need help. So, okay, here's what I'm going to do. I'm going to give you guys a few minutes to try it. If we start finishing this, I might come back and do that last example, but I don't want to confuse you. I want you to try some first. I do want to talk about the directions for this 26 through 44 even. So I would like if you guys could turn to that page in your books and let me talk about that for just a minute, and then I'll let you try them. Okay, on these, it tells us, suppose that point xy is in the indicated quadrant. Decide whether the given ratio is positive or negative. So let's look at problem 25. It says in quadrant 2, x divided by r. Okay, think about algebra. If you're plotting a point, if you're in quadrant 2, is x positive or negative?
Negative.
Negative. And I told you that r is always what kind of number? And a negative number divided by a positive number is? That's all it's looking for. So like if I did 27 in quadrant 4, y divided by x. If you're in quadrant 4, is y positive or negative?
Negative.
And x is positive, so your answer is negative. Okay, so 26 through 44 are not huge long questions. You're just telling positive or negative for those.